Have you ever wondered how an AI can answer questions about your company's private documents? Or maybe news that just broke an hour ago? Well, today we're going to pull back the curtain on one of the coolest techniques that makes this possible, Retrieval-Augmented Generation, or as everyone calls it, RAG. We're going to break it all down nice and simple.
So here's the big question, right? A standard large language model is amazing, but its knowledge is basically frozen in time. It only knows about the massive general data set it was trained on. It has no idea about your internal meeting notes or what happened in the world yesterday.
And this creates a couple of major headaches. First, that knowledge gets old, fast. Second, when the AI doesn't know something, it has this weird tendency to, well, hallucinate. It'll just make up an answer that sounds totally convincing, but is completely wrong. RAG is built to fix both of these problems. So here's our game plan. We'll start by looking at that AI knowledge gap. Then we'll introduce RAG as the smart assistant that solves it. After that, we'll get into the nitty-gritty. First, how you build the knowledge base, that's a one-time thing, and then what happens every time you ask a question. And finally, we'll talk about why this whole approach is so important, even today.
All right, so first up, let's really frame this problem. We have these incredibly powerful AI brains, but it's like they're locked in a library where all the books are from last year. We need a way to give them access to new, specific, and up-to-date information right when they need it.
And this is where RAG comes in. It's the solution. The best way to think about it isn't that we're giving the AI a new memory. It's more like we're giving it a super fast, incredibly smart research assistant that can look things up on the fly.
And honestly, the whole idea is hiding right there in the name. Before the AI even tries to generate an answer, it first retrieves relevant bits of information from some outside source. That simple two-step dance of retrieve, then generate is what changes everything.
You can really boil the whole thing down to these two fundamental steps. Step 1, find the right stuff. Step 2, use that stuff to give a good answer. We're going to unpack both of these, starting with how we get all our information ready to be found in the first place. So let's talk about that first big phase, setting up the knowledge base. This is the prep work. The good news is you only have to do it once. It's all about making your documents ready for the AI to search and understand. This setup process really just has 3 key parts. You start with whatever documents you have, could be PDFs, websites, you name it. Then you split them up into smaller digestible pieces, which we call chunks. And finally, you convert those chunks into a special numerical format called embeddings. Now, this chunking step is super important. An AI model has what's called a context window, which is kind of like its short-term memory. You can't just hand it a 300-page report and expect it to find one sentence on page 247. By breaking that report into smaller, focused chunks, like a few paragraphs each, you make it way, way easier for the system to find the exact piece of relevant information it needs later on. Okay, now for the really cool part, embeddings. This is how we translate human language, the meaning of our text, into something a computer can understand. Numbers. You take a chunk of text, you run it through a special model, and out comes a long list of numbers, called a vector. That vector is a mathematical representation of that chunk's meaning. And when you do this for all your chunks, you end up with this amazing map of meaning. You can almost picture it like a galaxy, where every chunk of text is a star. And the really brilliant part is that chunks with similar meanings end up clustering together in the same neighborhood. So a chunk about top-rated eateries will be right next to a chunk about best restaurants, while something totally different, like how to fix a car, is way off in another part of the map. And here's why that's such a game changer. It lets us move beyond old-school keyword search. We can now do what's called semantic search, which is a search for meaning, not just words. This is how RAG can find the right information, even if your question uses totally different phrasing than the original document. Okay, so we've done our prep work, our knowledge base is built, our map of meaning is ready. Now for the fun part. Let's see what happens in real time when you actually ask a question.
This whole process happens in a flash, and it's got 4 steps. First, you type in your question. Then, the system retrieves the most relevant chunks from the knowledge base. After that, it augments the AI's prompt with that new info. And finally, the AI generates an answer that's grounded in those facts.
So how does it find the right chunks? Well, it uses that same embedding trick we just talked about. Your question gets converted into its own vector. Then, the system searches through that whole map of meaning to find the document chunks whose vectors are the closest, the most similar to your question's vector. That's how it finds the perfect context. Now, we get to the augmented part of RAG. The system basically builds a new, special prompt for the language model. It's like it's saying to the AI, okay, listen up. Here are a few super relevant facts I just found, and here's the question the user asked. Your job is to answer that question, but you can only use the facts I just gave you. This is what keeps the model on track and prevents it from making stuff up.
At this point, you might be thinking, okay, this is clever, but AI models are getting bigger, and their memories, their context windows are getting huge. Do we really need this complicated retrieval step?
And you know what? That is a fantastic question. We're seeing models now that can process 1 million tokens at once. That's enough to read a whole stack of books in a single go. So it's natural to wonder if RAG is on its way out. But it turns out there are some really practical reasons why it's more important than ever.
So why is RAG still so key? Well, for one, it's way more cost-effective and faster. Sending just a few relevant paragraphs is a lot cheaper and quicker than sending an entire library for every single question. Second, and this one's huge, you get verifiable sources. You can see exactly what information the AI used to come up with its answer. Plus, it's easy to keep your knowledge up to date. Just add a new document. You don't have to retrain a massive model. And finally, it helps the AI focus. It avoids this lost-in-the-middle problem, where important facts can get buried in a sea of text. Which leaves us with a final thought to chew on. As AI keeps evolving, the future probably isn't a choice between one or the other, smarter retrieval versus bigger memory, but a combination of both. RAG is amazing at finding that perfect, targeted needle in the haystack, while a big context window gives the AI the space to reason about what it finds. The fundamental question remains, is it better to know where to look or to just try and remember everything?